Plan sheet types of view. Okay, what we have, we're going to talk about a lot of different types of plans sheets coming up, and I just wanted to go over what each one was. So if we're talking about a plan view, it's an overhead look. Yeah, the vehicles are a little large for the highway, but I wanted to give a point. This is a truck going to the west, and this one's going to the east or north and south, however you want to look at it. But that's a roadway, so it's a plan view. So it's an overhead view looking down on the sheets. Then you have a profile view where you're looking along that truck, right along the profile. We're going to have that. We're going to see that. So it's kind of a side view of everything. And then we'll see a cross-section view or typical section view, which is the front or back of the vehicles, as you can see here. So usually it's to show the pavement thicknesses, what's going on here on the widths of the highway, what we're doing. But so you have a plan view, which is overhead, a profile view, which is the side look of it. Then you have a cross section or typical section, which is the front. So we'll talk about typical sections in this video. Typical section sheets are included in the plans to show details and complete dimensions for proposed surfaces, bases, shoulders, ditches, and cut and fill slopes. Typical section sheets are numbered as sheet 2, as I talked about in the previous video. Regardless of the number of typical section sheets required, if more than one sheet is required, the sheets are numbered sheet 1 of how many you need. Let's say in our previous example it was 9, so 1 of 9, sheet 2 of 9, etc. The existing typical section information may be shown or summarized in a list on the typical section sheet when necessary. Existing features are shown as dashed lines. Okay, so if you see that out there, you'll see the proposed pavement out there on a typical section, and then you'll see in the background you may see some existing features, and they'll be dashed. Typical sections will be shown for a given station range. There may be different typical sections depending on the curvature of the roadway, and that's what determines the typical sections, how the curvature of the roadway is, what's going to happen to the sections. And let's just get into the typical sections. So here's a typical section sheet. This is one that's actually been built out there. You can see on a typical section sheet you have a half section on tangent here, and this is on US Highway 54 eastbound. And what it talks about in this little piece of information is you've got some pavement out here that they're overlaying or placing out there. You see a match existing, so they're matching the existing slopes that are out there, and you got the existing pavement below it. You can see that, so they're going through and doing that. You also see that you have a safety edge on here, so if it's anywhere less than 4 foot on shoulder, you'll get a safety edge there. Notes there just to remind construction or contractors to place that in there when it gets below 4 foot shoulder. You also see a slope out here, and this one's not labeled. It just has a VAR, or which stands for variable. So that means that from one station to the next it could be different. So it's a variable slope. You'll see dimensions on how far out this pavement is from US 54 survey. You'll see that the passing lane's 12 foot, the through lane's 12 foot. You have an auxiliary lane of 0 to 12 foot. You also have an overlay out here that's 36.9. So this typical section tells you a lot of information about what we're doing to this roadway out here. You'll see below it also has information. Where are we going to have this typical section at? We're going to have it this station range to this station range. Okay, so that's what it's going to do. Now in other station ranges there may be some other kind of occurrences that need to happen, and like in this detail we're looking at a median saw cut, median widening. So you come out and you detail this up and you talk about it's going from this station range to this station range. So this information pertains to those station ranges. And then you have a half section on a curve. So we had a half section on a tangent, and a tangent is a straightaway. Okay, it's a straightaway, there's no curve. And then when you get to curve, it changes a little bit. You can see there's some super elevation going on here with this half section on curve. We're going to talk about all these terms as we go, but you'll see that. And you'll also notice again, what's important is this typical section will take place during the station ranges they list below. Okay, so that's the important part about it. We want to see this at these station ranges. Okay, terminology, we'll talk about that. The PGL, which is the profile grade line, center line of roadway, or median. It could be either one of those. We use that. Super elevation, 4 to 8% maximum tilt in the roadway around the curves. And we're going to talk more about super elevation in a minute. 4 4% is for the urban roadways, and 8% is for the rural. Tangent is a straight section of roadway, no horizontal curvature whatsoever. So that's a tangent, and usually you'll get a bearing on that tangent. Cross slope is a percentage of grade from the center line to the edge of shoulder. So if you're looking at if you're standing from the center line looking out to the edge of shoulder, that's your percentage of grade. A variable generally refers to varying slopes or widths, not consistent dimension, and that's why they'll put varies there. Sometimes it goes from like 3 to 1 slopes to 4 to 1 slopes in areas, and maybe back to 3 to 1. It just all depends how much right of way they got and what they want to, how much of the in conditions that they want to see out there. So that sometimes they end up having to put vary in there. SP 125 and SP 250 are super paved material for pavement in 12.5 or 25 millimeters. And 1 and 2 in parentheses refers to a particular cross slope in the table on a plan. So if you see that, usually there's and we might have some examples here in a minute. So the note on the right, it says watch for any asterisks or double asterisks or parentheses on a typical section. They usually have a corresponding note, so that's important. And to get a full understanding of information on a particular plan sheet, you want to review all available notes. So let's go to the next slide. See what we got out here. Okay, roadway materials. Roadway materials are usually set by the AADT and the amount of truck traffic expected. BP is bituminous pavement and SP is super pave. Generally, a typical section will show the pavement material, thickness, and base material and thicknesses. So you can see in this example, we've got some information down here. They're using 1 3/4 super pave, and then they're using, let's see, 3 inches of super pave 250. So that's what they do. They point it into this area and they list it out so that you know what materials are being used. You can see there's a 6-inch type 5 aggregate base they're using as well. And again, with these typical sections, the important part is it represents a station range. So from this station to this station, we're doing this. Okay, so that's what this is about. Now we'll talk about some slopes. Okay, so we got cross slopes. Cross slopes are measured from the center line or the crown of the roadway towards the shoulder. On a tangent section, typically 2% slope on both sides of the roadway. So and with that, you'll see that all that's doing is trying to get the rainwater off the highway. On super elevated section, you have a typical 4% max for urban and an 8% max for rural, from inside shoulder to outside shoulder. And then you have back slope, or foreslope and back slope. These terms are used to identify the new ground coming off the shoulder and eventually matching up with the existing ground. So let's look at these examples. Up here you see parentheses. We see a 1 that says 2%. So if we come down here and we look at this area, this profile grade says look at number 1. Okay, 1 means this is going to be 2%. Okay, this one has 2. Instead of putting the note in here where it would be tough to fit, they put it up here in this little chart, and it says 2% for paved slopes. But if it's aggregate shoulders, we want to go ahead and do a 4%. And then if you have a 3 somewhere, it's going to say super elevation slope if greater than 4% for aggregate slopes, super elevation slope for paved shoulders. So these notes mean everything, okay? And that's why there's a 1, go find the note, see what it says. A 2, go find the note, see what it says. But these are the cross slopes. So the center line's over here somewhere, and we're looking out towards the edge of pavement on out. Now down here we talk about the slopes. Okay, you have a 4 slope. This 4 slope's coming off the edge of shoulder, and it's going down to a ditch. When you get to the ditch, then you'll have a ditch 4 slope, and this one's at a 3 to 1. You get to the bottom, you get an 8-foot flat bottom ditch is what that stands for, FBD. And then when you kick it back up to 3 to 1, that is called a ditch back slope. So you have a ditch 4 slope, ditch back slope. You have a 4 slope that ties the ground usually, and that's what those mean. More on the cross slope. Again, typically we use a 2% where it's a tangent and no curves. Okay, so if we got no curves on our horizontal, we'll end up with a 2% cross slope on those. So that's a good example of what that's all about. And you'll see the typical section also has all the different dimensions and the type of base we're using and whatnot. So all the materials listed, everything on that typical section. Now, MoDOT super elevation. What is super elevation? Super elevation is tilting the roadway to help offset centripetal forces developed as the vehicle goes around a curve. Along with friction, they are what keeps the vehicle from going off the road. And you can see in these couple of screens that shots that you can see there is some super elevating going on. This one's a little bit more ridiculous, but it's fun. Okay, must be done gradually over a distance without noticeable reduction in speed or safety. Okay, now here's a video. Let's see if I can get it to play. There it is. And this represents super elevation. So at AA, we're at a negative 2% on both sides for section AA. The car travels through and goes to section BB. We're starting to super elevate. We're at 0 on the right side and still negative 2 on the left. Then at C, we're going to be at a negative 2 on the left and a positive 2 on the right. And then when we get to a D, everything goes to full super, whether it be that 4% or that 8%, depending if it's urban or rural. And then we drive through the curve at the full super, and then we hit DD again. And at section DD, we're still in full super. We're going to go down to C, and when we start doing that, again, we're going to go back to the negative 2, positive 2%, and we're lowering out of that super. And you can see now we're at BB, which is negative 2% to 0%. And then you get to AA, and you're back to the tangent. So you're coming out of that curve, you're at the point of tangency, 0% or 0 or 2%, negative 2% on each side. And then we get a close-up view of all this car with Cardinal fans. Enjoy. Okay, typical sections. Still with typical sections, we're talking about drainage now. There's ditches out there, okay, and typical ditches include V-bottom and flat-bottom ditches. Ditch depth will be shown. And there's other types of drainage. If under drains are used, they will be shown in the typical sections. Splash pads will be shown if under drains are used. So on this left side, you can see there's a flat bottom ditch, 8-foot FBD. You can see that. Normally they'll show the depth of that, and you'll get your slopes on each side of that. On the under drains move water from under the pavement to the ditch in flat areas where water can infiltrate and cause the pavement to crack. So you can kind of see what we've got here. We've got an under drain going on here. We got comes out to a flat bottom ditch, and you have your pipe under your under drain pipe under there. Okay, stationing. The station is the horizontal measurement along a survey center line of a project. Okay, stationing shows where the typical section is relevant. Stationing will generally show which route, if more than one route exists on the project. Stationing is a known location according to the plans and is used throughout the set of plans to locate all objects. Station runs every 100 feet in English, and it's discussed further in plan sheets. So you can see, like I've been talking all along, the stationing is important. It just tells us where our typical sections are going to go. Okay, so we want this one from 592 to 671 on this project, which is a horizontal measurement along the survey center line. Okay, that's what it's all about. And that, let's see, that finishes up the typical section video.